Alhamdulillah, wassalatu wassalamu ala Rasulullah. Assalamu alaikum wa rahmatullahi wa barakatuh. This is the second lecture on chapter 10. In this chapter, we are studying about the data manipulation instructions. So, in section 10.2, we'll be discussing the data transfer operations. So, the data transfer is also related to the data manipulation. So normally the data transfer instruction involves the transfer of the contents from one word or register to another word. Let us see this by an example. So here if we see that we have data in this register N730. So here is the data, and again in N20 is the data. So suppose we want to transfer the data from N730 to N720. So what will happen when this data will transfer from N730 to N720? So the content of the N720 will change, but the content of N730 will remain the same. So let's see that what will happen. So after the transfer, you see the data in N730 and data in N720 is same. So there are several ways to move the data from one register to another register. So on this slide, we will be discussing the move instruction. So move instruction you can see from this tab. Whenever you will click this tab, you will get a block like this. So in this block you have two registers, the source register and the destination register. So whenever this block will become true, the data from source is moved to the destination. So here is a program for SLC 500. This is a ladder diagram program which is written for using the RS Logix 500. So it is normally open rung because the contact is open. So if you want to close this, just we will close switch A. So here it is written A as the tag, but of course it has a numerical number integer as the address. So at the source N30 there is a data, and there is a data at the destination N70. So whenever the rung is false, the data will remain as it is. But as soon as the rung become true, the data from N730 will transfer to N720. So the previous data will be overwritten. This means the previous data will be cleared and the new data will be written on N720. Remember, the data after the execution of the instruction at N730 will remain same, and the data at address N720 will change. So this is the program in RS Logix 500 simulator. We have the input contact A, which is normally open. Its address is I slot 1 and the address is 0. So this contact is associated with, this is the input switch. So this switch is also normally open. This means the rung is false. Initially there is 0 in N730, which is the source, and there is 0 in the destination over here. Then in N30, suppose we can change the data. Here this data we can change from here we can enter from the using the keyboard. Here we have selected the only decimal. It is possible to select binary or hexadecimal, other or octal. We can select over here. So here the appearance will come in hexadecimal or in binary or in octal, but here the data you will see in decimal. Secondly, when we will select N730, here in the address you will see the N730. Here N7 integer shows that we are writing in this register the integer numbers. So we start the simulation now. So here we are changing the number. So when we change it, this number will change it N30 immediately, and then when we come here and close it, the data transfer from here to here. When we open, the data will remain like this. If we convert here to decimal, you are seeing the numbers in decimals, but here they are the same numbers. Now again, if we want to change it to decimal, we can change it to the decimal, and it is possible to change this number using the keyboard. Suppose we put here 19. When we enter, you will see here is the 19 number, and when you close from here, it is transferred. But if you open it now, so the data will remain the same as it was previously. So like suppose it is open, so the data is not changing now. So move with the mask is an other instruction which can transfer the data from a register to an other register, but masking the portion of the data. Masking means that hiding the portion of the data. So here three registers are involved: the source, the mask register, and the destination register. So the mask register normally hide portion of the data, so partial data moves from source to the destination, but whatever the previous data was there in the destination, it will remain over there as it is. So let's see that what will happen. So here we see the block. We have three registers. One is the source, mask, and the destination. So masking refers to the action hiding portion of the binary word before transferring it to the destination address. So here we see the source data is, suppose this is the number which we are seeing in the binary, and we have mask in the hexadecimal. If we want, we can change it to the binary as well. So this we are showing it here so that you can see the mask data. This mask data is associated over here, like here are 4 zeros. So what is going to happen, that the original data is this one in the destination register. So what will happen, this data will transfer here, and here is also one, this all data will transfer here, but this and this data, because they are making 0, so this portion at the destination will remain unchanged. So what happened, this data is transferred here because in the mask we had here ones. Again this whole data is moved because here we have 1, so this data is also moved here. This was the previous data over here, so this data is not moved because we have masked this portion, so the previous data will remain. So this is again the ladder diagram in RS Logix 500 simulator. In this block, this is move with mask instruction. So the source is B30, mask is B31, and the address of the destination is B34. In all of them, the data is different. Here it is difficult to understand which portion of the data will be transferred to the destination when the rung become true. So this we can see 8B31 in binary, like from here, and if we come up to this, it is 1. So this means the data associated with these bits will be transferred. This means the data from here to here will transfer to the destination whenever this rung will become true. But the data where it is written 0, like 1010, will not transfer over here, and this data will remain the same as it was before the transfer. And over here again, this is 111. This means this data will transfer from here to here. Just remember one thing, here we are writing 000, which hide this data. It is not necessary that it should be a complete byte. It is possible that they can be any number of bits. Like suppose you can take 5 bits, 2 bits, 6 bits, 9 bits, any number of bits you can hide, and any number of bits you can make them transparent. When I put over here 0, I am saying that we are going to hide the data associated with these bits. This means 1010 is hidden because here we have 0000, but here the data 1010 is not hidden because here we have 111. So this data is transparent and this data is hidden. So whenever this rung will become true, so this one is originally A, this is again, if I am seeing, this is A and this is also A. At the destination I have here C, then again there is C, then again we have C, then again there is C. When this rung will become true, when I close this will be closed, the rung will become true. When this rung will become true, this A will move from here to here. Secondly, the second A will also move from here to here, but this will remain unchanged and this will again change. So let's see this action in the simulation. So here if you see, if you want to see the same data in decimal, we can do like this. If you change them to hexadecimals, you can again see in the hexadecimal, you will see like this. Now if we close this one, what will happen? The data will transfer from here to here, but you will see now the data is changed. So what happened? This data and this data is same, this data and this data is same, but the C1 is, the third nibble was not same. Like you see here, this C is not changed. In RS Logix 500, there is an other instruction to what we say BTD, the bit distribution instruction. Using this instruction, any number of bits we can move from one place to another place in the same register or word, or between two words. So first we are going to take an example that how to transfer the data within the one word. So here if we see, the instruction is written source is N7020 and destination is also N7020. So this is the transfer of the data in the same register or in the same word. So here it is a source bit number 3. This means the data which we want to transfer, it starts from bit number 3. Then it is written length 6. This means from 3 up to 6. So total number of bits over here are 6 and they start from 3. You see 3, so bit number 3, 0, 1, 2, 3. So this is bit number 3. From 3 we start and we come up to the 8. So they are 1, 2, 3, 4, 5 and 6. Then it is written destination bit number 10. This means it will start from this one, and what will happen, this complete data from here, it will transfer to this position whenever this rung will become true. So now we will study about the using the BTD instruction to transfer the data from one register to another one, and by selecting the number of bits. So here it is written N720, so this means this is the source register, and N722 which is the destination register. So here you see these two registers are now different. Here it is written the source bit. So the source bit is number 3, like 0, 1, 2. So this is bit number 3. Then we are writing over here 10. So it will start from 3 and it will reach over here. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. And fundamentally this is the last bit is bit number 11, because it is 12, bit number 12, 13, 14 and 15. So this is bit number 12 in the register. So now this data we want to move. Here what we are saying, destination bit is number 5. So this data will move to register N720, this register, but the first bit will start from bit number 5, and then it is going to reach up to bit number 14. So if you don't understand it, listen this portion again and again, and also simulate it in the RS Logix 500 simulator. You have already the CD with you, so I think you will understand. Even then, if you don't understand, just write in the comments and I will come back to you as soon as possible. So here we will discuss an example in which we use the move instruction to change the preset time of a timer. So this is the timer T41. So the preset register address will be T4 ratio dot PRE. So here with the move instruction, we have written 10 and the destination is T4 ratio 1 dot pre. So now if we select from the selector switch 10, this 10 will move from here to this register, but this register is associated with the preset register of T41. So this 10 will move from here to here. This means the preset time of the timer will become 10 seconds. Similarly, here another one, when we select the selector 5, so it can be 5 seconds with the similar explanation. Remember, either we can select 5 seconds or 10 seconds. We cannot select both 5 and 10. Can you explain why this can happen? So try to answer. The second thing, can you change this program to the program in which the light should become on only for 10 seconds and become off for 5 seconds by just pressing one switch, PB1. The present program, how it is working, when we select the 5 second on the selector and we push the PB switch for 5 seconds, and the done bit will become on, so the pilot light will become on. On the other hand, whenever we select 10 second and we push the PB1 for 10 second, so after 10 second or more second, PL1 will become on. But if we press it for less than 10 seconds, PL1 will not become on. Similarly, when we put it at 5 seconds and we press the push button for less than 5 seconds, PL1 will not become on. Now we select the example. In this example, originally we use move instruction to change the preset time of the timer T41. So here at N7 colon 1 register, which is the source, the integer number is 100, and in N72 the integer number is 50. So whenever SS1 selected in this format, because this is normally closed and this is normally open. So by default, a T for one preset time, you will see 100. So whenever the timer runs for 100 seconds, the output device will become on, which is the pilot light over here. Similarly, if we select the second one, so this means this will become open and this one will become closed. So this 50 will change to 50. This means with the move instruction, we can change the preset time of a timer. So whenever it becomes 50, so the base is 0.1, so it will become 5 seconds. What is the meaning? When we select SSN1, here will be 100, 100 multiplied by zero point 0.1, so the timer will work with 10 seconds. And after 10 seconds, the done bit will be enabled. When we select this option, this will be deselected because of the selector switch. So this 50 will move over here, and here you will see 50. So 50 multiplied by 0.1 will be 5 seconds. So when the timer runs for 5 seconds, the done bit will be enabled and we will get the pilot line on. So let's see what happens in the simulation. So we selected 100 and again we can select 50. So now we have 100 over here. When it become 100, here the pilot line will become on. So when this done bit become on, you will see this is on now. Now the second one we select over here, this here it become 50. So when it will reach to 50, the timer will run for 5 seconds and you see here this is on. So the rest of the characteristics of the registers of a timer you have studied in chapter 8. So here is another example, and in this example we can select the different number of count to make the pilot light on. Like suppose we have a place where we can put only 50 items, then it should show us the parking become full with 50 cars, or the box become full with 50 items. Different type of places you can use this. Clear? The address explanation is same. Like the address of this preset register is C colon 1 dot pre. So this addresses, and this address is same. Now if I select A, this means the counter can count maximum 300. If I select B, the counter can count only 175. And if I select C, the counter can make only 50. And of course, for the counter, we always need one reset action. So the reset action is over here. Now the question is, there is a mistake in this program. Can you identify that mistake? The second thing, If you can identify the mistake, how you can uh, change the program to rectify the mistake. Stop the program here and write your answer, then compare with my answer. So my answer is that, like, if we select A, B, C, three all of them or two out of them, so what will be the counter uh, preset time? So this is why it is a mistake. Like one other two should be open, only one should be selected at a time. And to do this, we must be using a selector switch. We should not be using the switch which on off switches which can be selected two at the same time. We should be using a selector switch. The second thing, the selector switch is the number of operation for the selector switches are small. So then we can use the similar on off switch like this, but then we can use the Boolean algebra logic that when we press A, the other two should become automatically disabled. If we select B, then the other two should become disabled, and if we select C, then B and A should become disabled. So if we do this type of thing, then it will be a better program. But again, the question is that when we select A, B, C, so all of the three will be deselected. If I select A and B, so this means it can select only A. So you have to make some logic for that one. In the previous section, whatever the data transfer we studied, it was originally complete register from one place to another one, or number of bits from one register to another one. But sometime we need to transfer the data from file to file. So one complete file is transferred to another complete file. So this is one type of file to file transfer of the data. And we have from word to the file, like one word, and we want to place the same word in all registers of a file. So this is word to file movement. And another type of movement we need, and that is from file to the word. So this one is understandable, easy. This one is understandable, but here what will happen? So fundamentally what happens, sequentially the data will transfer from file to a word. Like suppose first this one will come, then the other one, then the other one, the other one, other one, and the other one. This is how this transfer will happen. On the next slides, we will study the detail of this. So before going to the instructions for the transfer of the data, let's understand that how we can represent the number of words in a file. Suppose the data is starting from N730, and suppose there are 8 words, then we start from N730 to N737. So the file number will be N730. It will start from this, and its length is 8 because the total number of words in this file are 8, like this is 1 2 3 4 5 6 7 8, and because we start the numbering from 0, so it will start from N730 to N737. So now we will discuss the instruction. This instruction is the file arithmetic and logic instruction, and it is used to copy data from one file to another file. So if you take in the RS Logix 500 and in the simulator, similar type of block you can get. So in this block you have, these are the registers: control, length, position, mode, destination, and expression. So I will explain all of them one by one. So the first instruction is control. So control word uses 4 bits. So the first one is the enable bit, done bit, error bit, and unload bit. Enable, done, error, and this bit you can see also inside the register, but no connection you will find in the output. The second one is the length. So length represent the length of the file words, as in the previous slide we studied that. Like suppose I select 8 and the first address is 30, so the last will be 37. Then we have the position point, and the position point is the point from where the transfer will start, or the data will start from the point. So that is the start point. We have discussed this already. Then we have the mode. In the mode, that all the data should be transferred in one scan, or it should be incremental, like at each scan one by one should be transferred. So these are the options in the mode. Then the destination. So again, the destination address we have to write, and of course the length of the destination and length of the uh, data from where it is being transferred should be same. What is expression? Expression contains address, program constant, and operators that specify the source of data and operation to be performed. The expression entered determines the function of the FAL instruction. So now on this slide we explain the FAL instruction. So control, this is the address of R ratio 1. So length is equal to 6. This means 6 words should be transferred. So this is like 1, 2, 3, 4, 5, 6. From where it should start. So expression gave us this number n7 ratio 20, so it will start from n7 ratio 20. So they are 6, so this means 20. So 1, 2, 3, 4, 5, and 6. So from N720 to N725, total number of words in this file are 6. Similarly, it is written destination, so it is S750. So it will start from S750 to N755. So whatever the previous data was here, whenever we close this switch, this rung will become high. So this means true. So whenever the rung become true, the data from this expression will transfer to the destination, and whenever the data will transfer, so the enable bit will become high, done bit, and if there is an error, it will show that there is an error. And mode means all. This means only in one scan all the data from here will move to this position. So from in this file arithmetic logic FAL instruction, we can move the data from a file to a word. So what happens here, it is written R66 and the length is 5. This means it will be operated at 5 words in a file. So the expression is 29. So this means that it is file number 29 oblique 0. So it will take like word 0, 1, 2, 3, 4. So in total they are 5. Now the destination is N29 uh, 0. So we come to data is N29 5. So this is the destination file. So when first we close this, the data from the word 0 will move here. Then we again open and close. The data will move from here to here. Then next one, then next one, and then the final one. And this is how the data will shift. So in this one, the data, the way it is moving incremental and it is from a word to the file. So here we are writing the length is 6 and position is 0. And then we are saying the mode is incremental mode, destination is this complete file, and the expression is N700. So for the first time when we close this, the data will move to here, then it will move to the next one, then this, then over here. With each click it will be moving until the last data. So they are how many? 6. So from 1, 2, 3, 4, 5 and 6. Copy instruction and fill the file functions or instructions are the speed instruction that operate more quickly than same operation with the FAL instruction. In fact, when COP or FLL instruction copy the source data to the destination, these instruction does not compare the source and the destination data, and they don't perform any logic for the matching of the data. This is why these instructions are fast. So COP FLL instruction can copy the complete one word to the complete file. Like over here, whatever the data is N15:5 will be copied just with one instruction from N15:5 to N20:1 up to N20:6, and the first destination address determines the first address where the data will be transferred, and this 6 is showing that the total number of registers in the file are 6. So here from 1 to 6 the whole data will be transferred. Uh, this data transfer will happen whenever in this program, ladder logic program in RS Logix 500, the contact A is closed. So in this example, the copy instruction is used to transfer the data from N10 colon 20 to N12 colon 10 with the length 4. And in FLL, the data is transferred using from 0 to 4. So here the data is transferred from file to file, but here the data is transferred from a register to the complete file. So whenever we will push to PB1, whenever this will be closed, whatever the data is N10, it will be transferred to N12, and in PB2, if we want to clear the data in N12 colon 0, so it is very easy. We put in one register just 0, and then with one instruction we can move the 0 to the whole file at the destination. So this instruction is very fast and quick for removing the data from a register from a file. Of course, we can use it to single one register. If I write instead of 4 over here 1, so it will clear the data only from one register. And if I write over here 8, so the data will be removed from the 8 registers. So this way we can easily clear the data or delete the data from a file. So thank you very much. Uh, with this, the lecture completes on section 10.2.